Hi everyone, we are Seban, Daniel Luzzatto, and Sharon Atlan, and we are here to present our project in fluid mechanics. For our calculations, we assumed no friction, steady state, continuous flow, incompressible fluid, and constant initial velocity. Here's a model we made using a 3D modeling software representing our experimental setup that helped us understand and visualize the hydraulic jump phenomenon. First, we defined the control volume region. Then we defined the initial and final height and velocity of the water, H1, H2, and U1, U2 respectively. Using conservation of mass, we found a relationship between velocities and heights. Then, we applied conservation of linear momentum and derived the second equation connecting heights and velocities. When combining these equations, we obtain a quadratic expression for the final height, which we then solved, ignoring the negative non-physical solution. Here's a 3D simulation that replicates the hydraulic jump phenomenon. In the real experiment, we measured the velocity of the water beforehand by filling a container of known volume. We recorded videos of the hydraulic jump experiment using our custom setup with varying initial velocities to find out the minimum velocity required for a hydraulic jump to happen, and link the initial velocity to the height of the jump. Let's now look at our results. We compared the measured final height of the hydraulic jump to the theory, and we plotted a graph showing the height of the hydraulic jump as a function of the velocity of the water. In blue, we show the threshold to get a hydraulic jump, which was found experimentally. Note that our results differ from the theory for various reasons such as friction, our setup being not ideal, and that we considered the velocity of the water entering the control volume as being the same as the one out of the hose. The dissipation of kinetic energy through heat is a widely recognized application of hydraulic jumps. The energy dissipation rate can be determined by combining the rates of kinetic and potential energy. Then we can subtract these values to obtain the energy converted into heat.
That's all, folks.